Sorry, I'll start again. Bit of science at home, some cloud making, some rainbows and colours, and maybe a quick explosion at the end if we're lucky. So, thanks for joining. It won't be a very long experiment. Cloud making is all about four things: water vapor in the atmosphere, the right pressure, the right temperature, very closely linked, and some particulates in the atmosphere. So, it's a pressure, and we can't see much happening. And I let it go. I'm changing the pressure, it changes the temperature a little bit. Not much is happening. We're missing one critical bit of ingredients, and that is the particulates. So if I'm going to light a little match here, because I want the smoke particles to get inside the bottle, I have to undo the bottle and put some smoke in here. That's all it needs. I've now got a whole lot of smoke particles in here. So what I'm going to do is change the pressure. Oh, we have a cloud. So high pressure.
The fog is the cloud.
No cloud.
You can kind of.
Low pressure. Have a cloud. So that demonstrates we've got some smoke particles in here. If I keep doing this, ultimately there will be no cloud because the particles drop out. And so there's nothing to attach the water pressure, the water vapor to. So now we're going to move on and try a different version where we put some hot water, cold water and particulates in there. Won't be a second. Let's do that with a little bit of hot water. So this is a different technique because I'm trying to use the hot water to create the water vapor. We're going to put some hot water in here. That puts a whole lot of water vapor in here. We put the cold on top, a lid with some ice on it, and then it cools it down to the right temperature, and then we need those particulates. So let's try that. We're going to try it on with a bit of colour. So let's keep going. Let's chuck a little bit of hot water into here. There's the hot water. We've now got, it's very tricky obviously to do this with your hands. These bottles we're going to use later, won't be a sec. So we've got some hot water.
Just pause until you've got your...
How are we going?
Where does the link?
Everyone is wondering where the link is because they're all on the other page waiting. And
Where do you want me to send the link?
Doesn't happen, doesn't happen.
Where do you want me to
Things
send
don't
the
work.
link?
Sometimes it doesn't work.
We can send the link somewhere. Where ya?
Oh, the link isn't working. I know, I'm trying to tell Rob that. I'll send you through a new link and it can go.
Copy link.
I can't get it on the chat because I'm on multiple different systems.
I'm sending it an email to Emma right now.
Yeah, cool, great.
Let me start again.
Yeah, you've got 100 and something people on the other.
Ah. Ooh, all happening.
Alright, so we're going to start again.
Let's start again.
Just real quick. Can I help?
We're just going to catch up ourselves a little bit here. Our cloud making experiment, we're just trying to get the link out to everyone. Do apologise for our IT issues. We're making clouds in either a bottle like this as we change the pressure, or at the moment we're trying to make it here with some hot water, cold, and we need to create a cloud by putting a bit of this in here. Particulates. And now we have a cloud. So what's happening here, and that works best if I let the cloud out, is cloud making.
And have you done like why the ice? Why you need the ice?
So we need the ice to cool the water temperature down. So clouds the temperature of a cloud is usually between 0 and 10 degrees. It's pretty cold up in the atmosphere. And so we need to cool it down.
So the water
It's the difference
vapor.
between what steam is, which is near 90 degrees, and water vapor. Now, so I'm going to go back. We're making clouds two different ways. One is we need the particulates in here. So my hairspray, which I don't use that much of, we had to put them inside. What's happened is that my clouds kind of disappeared. We might have the right amount of water vapor. It's still got hot water generating some vapor. We're cooling it down with our ice on top, but I've run out of particulates. I need to actually put more in. So we can use whatever we like. Is our cloud coming back? Yes. Letting some cloud out. So, a bit of cloud making. I'm going to try one with a different colour, because why not? No, I can't. We're almost finished this bit, and then we'll move on and try out these ones. Different type of cloud. Now, I've still got my ice. I've got the right water vapor. Got some ice to cool it down to cloud temperature. But I need some particulates, and I thought it'd be nice to try some coloured clouds. I'll try it out. So what happens here is we can't really create a coloured cloud. The colour is still the same. So the liquid's changed. I thought I'd put some jelly in. And there's a little bit of a cloud happening here, but the particulates, like the jelly crystals, go straight into the water. They don't actually hang in the air. So it's not very useful about creating a cloud, because I really hoped today to try to create a jelly cloud. Can you imagine walking through jelly clouds? How cool would that be? You'd be eating jelly all the time, wouldn't you? But jelly doesn't work like that. But the other ones certainly do. So that's why the smoke particulates, I'll use this jar. I want to get a new bit of ice. So I've got some really hot water in here. I've got ice on top because steam is not where the cloud is. I'm going to put some more hot water in.
Dad, everyone will just.
So here we are trying to make some clouds. If you've just joined us, apologies for some of the IT. I need 4 things to make a cloud. I need water vapor in the air. I need the right pressure, the right temperature of the air itself. And I need what's called nuclei, particulates, for the water to attach to. So if I don't have any particulates, then I've got a bit of steam coming off here. It's condensing around the edge, but it's steam. It's not a cloud. Clouds are usually less than 10 degrees. So what I need to do is add in these particulates, and if I do that, then, and I've got some hairspray, don't use much of it, but today's a good day. And I put some hairspray in, and now it's got particulates. And you should start to see the clouds emerging. So the steam's already gone. This is actually cloud. This is just a cloud inside here now. And I can tell the difference because I can, 2 things, it behaves differently. It starts to wave and move around. Steam would go along straight up very quickly. And also the temperature, okay? It's really cold. It's still kind of warm, Isabel said, because the jar itself is quite warm. So the ice is important to cool it down to the right temperature, and then we need those particulates to stay in there. I'm just going to do another one because It looks kind of nice when there's different colour. I'll just do this one.
This is red food dye.
Bit of red,
You're gonna
just to have the contrast. So we put our hot water in. And I've got my ice. So at the moment, I've got water vapour, because it's coming off the hot water. I'm cooling it down at the top, but I don't have the particulates. So we need to add something in to get the right temperature of that water vapour up there, but it's got to attach to something to create a cloud. So, a bit of spray. And now, we have a nice cloud forming in here. And you can see it. I can let it out. I have to put it down a sec. It's very hot to hold. Got a lot of hot water in there. That'll stay around until a few things change. This cloud will stay here unless the particulates drop out. And when the particulates drop out and it takes the water, that's rain. Or the pressure or the temperature changes. And the temperature will change a little bit eventually, whereas the heat from the water and the jar comes out here into the room. But otherwise, it's actually going to stay there quite a while. So we really need this ice. If we didn't have the ice there, the water vapor wouldn't get down to the right temperature to then form in the atmosphere. So particulates, this happens all the time. Every time it's raining, it's ironic to talk about clouds today. It's obviously very wet outside, but it needs these particulates. And most of the time, they're all natural elements floating through the atmosphere, you know, and it can be little bits of dust and these kind of things. Occasionally, it can be pollution. So clouds will form, attaching themselves to pollution, and then the problem is that then falls back to the ground and we get some polluted rainwater, quite famous in Germany in the 70s and 60s, because they were emitting lots of sulfur dioxide. Which is relatively toxic. It then attached to these water vapors when the clouds came across, and then came down as acid rain. Not very nice. Wasn't that acidic that you would get burnt if you were out in the acid burn, but still. So, and what will happen with climate change is that the changing to the pressure and the temperature of the globe will change where clouds form. If we change the way where clouds forming and how much rain that they hold, then you'll change where you get rain across the earth as well. So that will have a huge influence.
Clouds aren't red.
So this one's gone along for quite a long time. I could probably put some more particulates in here. Smoke particulates. Just a tiny, tiny little bit of smoke in here. You can't see it, and this is what happens all the time with clouds. You can't see you can't see those particulates, but if we try and put some more particulates in, we'll see if we can generate another cloud. Oh yeah, and so that happens quite quickly. It's actually fogged up quite a lot straight away. So that's what fog is. Fog is a cloud. Like fog is just literally water vapor. Fog, we just call it fog rather than a cloud because it's right down at the surface of the earth, not up in the sky. Clouds can be up to about, 10, 20, 30 kilometres above the earth, the really, really high ones. Cirrus, they're called. This one's gone quite well. So smoke's got a lot of particulates in it. If you remember the bushfires, and there was a lot of discussion about how many particulates were in the atmosphere. They were really big particulates that have big health impacts, but these little ones are just enough to attach the water vapor to, and we keep letting the cloud out. So there we go. We're going to move on, and we're going to have a little quick play with a different version of a cloud. Not really a cloud at all, to be honest. So often we do these kind of fun experiments at home. A bit of ice. You guys can do this at home. This is pretty easy. You need ice, you need a jar. You need an ice and jar, but this next one you can't do at home. So this next one is colloquially known as the elephant's toothpaste
Do
experiment.
not do it at home.
It's not that you
is-
cannot do it at home, is that you literally can't. So these chemicals I'm going to use to create a bit of a rainbow pattern are only available if you get police approval. So the last couple of days I had a bit of fun engaging with the police to make sure that this was an approved use of the chemicals, which it is. This is all an approved use of rainbow pattern. We have in here potassium iodide is the solution. Solution means it's mixed with water. And we have a little few bubbles, washing up detergent. And they're all the same. The food dye is a different colour. Exactly the same solution, it's just different colours because they've got different food dye.
What is potassium iodide?
So potassium iodide is just two chemicals that are bonded together, the potassium and the iodide. And then this is hydrogen peroxide. And so these chemicals are things that you guys can't get over the counter, as I said. So what's going to happen here is that as I pour this in, the potassium and the iodide separate, and it creates, hydrogen peroxide is a very, very close cousin to water. So it's kind of water, but it's kind of not. It's very different.
It's like
And it's going to separate and actually create water and oxygen, and it's the oxygen that, huge generation of oxygen that's coming from these bonds in here.
because hydrogen peroxide is H2O2 and water is H2O.
Yes.
So there's one extra oxygen.
You can't see my daughter Isabel on the camera here, but she's some expert comments from chemistry in the background. This is also called an exothermic reaction. Exothermic means it releases a lot of energy and heat. There's opposite of that is endothermic, so it would go very, very cold. So that's about transfer of the energy into the compounds. This one's going the other way. There's a very famous and I guess quite useful exothermic reaction, which is when you burn petrol, and that's how your car drives. It is an exothermic reaction, and that's how the pistons turn and your wheels turn. So I'm going to do this, and this is going to be only people nearby with safety glasses, so I'm able to participate in this one. I'm just going to clear out the space a little bit. My jelly crystals, my jelly cloud that was no cloud, my matches for my particulates. I just want to clear a little bit of space because when this goes, it really goes. There is a simple way to do this, a little bit something like this at home, where you don't need police approval for chemicals, but the reaction is really slow. And so when you're trying to do something online like this, it's a lot more fun if it's a bit far faster, isn't it? I have my measuring here because I have to weigh, to get this reaction to work properly, we need to have the exact right ratio of the potassium iodide and how much hydrogen peroxide I'm going to pour in. So a lesson for you people that do maths, fractions are very important. Just like they are when you go cooking, when you're trying to do some cooking at home, you've got to get your ratios right, how much flour, water and so on you're putting in. Particularly important for this one. So we did a trial yesterday to ensure that we had the right ratios. And the more volume with the right ratio creates a bigger explosion. If it's not the right ratio, then nothing, if it's really out of whack, then either nothing will happen or something quite drastic will happen. Let's hope we have the right ratio. So yes, pay attention in your, I just have to look up here to get the right amount of hydrogen peroxide. So this one's going to be, hopefully not ruin our kitchen altogether. I'm going to try and do this one, then this one, then this one, this one. The risk if this doesn't work is if this one's too big, then I won't be able to get a chance to do these. I'll try and do it as quickly as I can, but this is going to be my challenge. I do have safety glasses on. I'm wearing gloves as well, which is really important. So are we ready? Let's a test of how well my maths was working last night to get the right ratios. So elephant's toothpaste. That'll do that one. Put the right amount. That's starting. That is a little less spectacular than the others. Oh, now it's really starting. The green started. I've got time to do all of them. I think I've got the right ratios.
You might be able to see there's a whole lot of steam because of all of the.
All right, we have our rainbow. And the steam, this is the exothermic. This proves it's exothermic. This is all that steam. This is the heat. And the heat is, as I said, it generates water and oxygen. It's actually the heat is heating up that water so much, it's boiling the water. So that's what happened while this was actually happening at the same time. And that was elephant's toothpaste. Someone tried to do an experiment to do the biggest one ever, and they essentially did it and covered their entire house, and it was about this high. But they had these like huge drums of hydrogen peroxide that they were pouring in. So luckily we didn't go that much, and I don't think it even went off the edge, so it's good. So a cloud, still a tiny bit of cloud there, not much, but anyway, that's about it.
Rainbow.
So we've had a few experiments with making clouds at home, and then we have some elephant's toothpaste, and I've got to make sure this all gets cleaned up properly. So have a great day, guys. Thank you very much for watching. Apologies again for our IT issues at the beginning and people joining late in the program. Didn't miss too much. This was the fun bit. Have a good day. See you later.